Dear students, welcome back to one more lecture in module 5. Today we are going to learn about PN junction diet and how it works. PN junction, as the name suggests, it's like a junction made up of P-type semiconductor and also N-type semiconductor. You take P-type material and N-type material, just combine them, physically just join them. That's what your PN junction is made. Now this is called diode. Diode means two. Electrode means two electrodes are there. One is anode and the other one is cathode. The positive side usually known as anode and cathode is a negative terminal. So now what happens here is the moment you connect P-type semiconductor, P-type means having more acceptor atom or valency 3 trivalent atoms which can accept electron. That's why we call it the acceptor doped semiconductor. Here there are N-type semiconductor, it's a pentavalent dopant, it will be there, or which can give electron. That's why you have a free electron here, and because this can accept electron, there is a like deficient electron deficient phase is there. That's why it's known as your P-type or hole rich semiconductor. In this, your majority charge carriers are hole, and in P-type semiconductor, and minority charge carriers, obviously the electrons will be there in the semiconductor. And here there is the excess of electron as a charge carriers, and they have minority charge carriers as hole also. Now what happens when you combine them like this is, the moment they come in contact with this, the acceptor atom, you'll see that there are a lot of donor atoms in this N-type semiconductor. So they will they will cross the region and they will come here. And the same happens with here. The donor atoms, either there are a lot of acceptor, means the holes from this will move to this side and electrons from this to move to this side. So there is a physical diffusion happens. The electron atoms, the pentavalent atom or the excess electron, they will move here because there are holes, and they will move here because there are excess electrons. Now as they move like this, even the pentavalent, you have excess electron, it is a neutral entity, isn't it? The pentavalent, it has equal number of electron and nuclei, the positive charge, and the parent semiconductor also has the equal number of electron and nuclei. So this is a neutral as an entity. Now when you get excess holes, they will form a slight positive charge here, isn't it? The holes that is coming from here, they will deposit here, they will create a slight positive charge to this one, and when the electron from this side jump here, they will combine and they become neutral. But as such, this is a neutral entity, so the excess electron will create a slight positive charge. So this diffusion will happen to a point where there is sufficiently large positive charge on N side and sufficiently large negative charges on the P side is developed. So this is also known as space charge region, or this region. What happens is there are no free electron or no free holes to conduct. So this is a depletion region, it's called, because there is they are lacking electron and hole. And this, when they grow to sufficiently large, what will happen is they will stop further inflow of holes from this side, because the holes, when it comes, it sees a positive region here, so it will be repelled. And when electron comes here, it will see a negative charge here, so it will repel back. So they will remain as a N-type after some beyond certain point. So they no longer electron will go here, no longer holes will going to come to this side. So this region is known as your depletion region. So that's what we learned here. So what happens is, electron, they go to the other side, they diffuse to the P-type region, and holes diffuse to the N-type region. So they form a neutral, or the region which lacks free electron and free hole. So this region is known as a depletion layer or depletion region, they call it. So this is essential, this is required to prevent further inflow of electron to this side and hole to the other side. So this region is useful in various cases. And what are the applications, and when you connect it to circuit, how this is going to change, and with that how the characteristics of the diode is going to change, and how it is affecting the other things that we are going to learn in a minute. So this is what I was telling you. The number of holes diffused to n side, and a large positive side will accumulate on the n side, and same happens with negative side will accumulate on p side junction. Such region is depleted of free moving charges, so that's why I call depletion layer or depletion region. Okay, and this is also called space charge region. If the depletion region becomes wide enough to the point there is no further hole can cross the junction, thus the depletion acts as a barrier. So this blocks the flow of electron and holes to the other side. Now when you connect this, okay, when you connect this to a circuit, so when you look into any circuit, if you find something like this notation, this is your diode, and you see this is the arrow mark and there is a bar kind of thing. So this is your p type and this is your n type. So if you look into your diode, there is it's a dark color thing, and a light gray color, that is your n type, that region, and the other one is p type. So if it is connected like this, this is a forward biasing. So this is a user notation, so this is for your information. Now when you connect it into a circuit, there are two possible connections you can make. So or the biasing, the connection in connecting it to a circuit is known as your biasing. Two types of biasing you can have, either forward or reverse. What is forward biasing? Forward biasing, what you do is you connect p type to the positive terminal and n type to the negative terminal. Now what happens when you connect like this? P type, then the positive terminal is connected to the p type, it will push the holes which are positively charged towards the barrier, and the electron will be pushed towards the barrier because there is an n type terminal is connected. Now because this is a barrier, so it need to be broken. So the more and more electron comes, more and more holes comes, they will get sufficiently large energy to break this barrier. So initially you require that small energy or small voltage to break this barrier. Once this barrier is broken, what will happen? The electron will flow from this and holes will flow from this. They will give the continuity to the circuit. So there will be flow of current in this circuit once the depletion layer is broken. Now if you connect it in the reverse, suppose you are connecting to reverse bias. What do you mean by reverse bias? P you connect to the negative terminal, N you connect to the positive terminal. Once you do that, what will happen is this positive terminal will pull the electrons towards itself, and p type terminal, when you connect to the n negative p, when you connect to the negative terminal, what will happen is holes will be pushed towards this side. Now once they are pushed towards this side, this depletion region will increase. The electron and holes are pushed away, pulled away, so the depletion layer will increase. So once that is increased, there will be no flow of electron. But you remember this has a electrons also. P region has a minority charge carrier as the electron, and N region has a minority charge carrier hole. So they will conduct some electricity. So very little current will be flown through this region. So that is because of your minority charge carrier. So when you connect this in the negative bias or the reverse bias, it will appear that there is a no flow of electron, or it will act as a switch which is open. Now the characteristics of PN junction, like VI characteristics we call it. Why we call it VI? If you apply voltage, how much current flows. So that characteristics, when you see or when you observe, this is what you will have. So initially you will not get any current in the forward bias, because this much current or this much potential is required to break that barrier or the depletion region. Once the depletion region is broken, large amount of current can pass through this junction. But in the other case, when you change the direction of the potential or you connect in the reverse bias, what will happen is very little current will flow, and this current is because of your minority charge carriers. Okay, very little current flow. If you remember, recollect your experiment, PN junction characteristic, you will see that in the physics lab, whatever you have done, In the forward bias, there are milliamp of current was flowing for even for less than 1 volt. Okay, you would have done up to like 0.5 volt. This is starts, and 0.6 to 8 volts. You see a large amount of current flowing. But in the reverse bias, even for say 10 volts and all, beyond 10 volts also, you have micro amperes, like 5 or 10 micro amperes of current was flowing, and because of the minority charge carrier. But you cannot go on like increasing the voltage beyond certain points. You will break the, or you will spoil the your diode, so it will no more function. So that point is known as the breakdown voltage. Okay, at one point where it is completely breaks the your diode. Okay, so these are about the VI characteristics. So when you draw the VI characteristics, with a small voltage it will go, and this is more likely, it depends on the band, how much band gap is there for the each of the each of the material, so that you also can find out. And this is all about PN junction diode. So we'll learn about the devices, keeping this in our mind. Like some of the devices they work on the forward bias, some of the devices they will be working on the reverse bias. So remember, the reverse bias, the current is carried by the minority charge carriers. In the forward bias, the current is carried by the majority charge carrier, and little energy. Initially there will not be any energy. That is because of the depletion region, which is a barrier which need to be broken. Okay, so that's all for this lecture. In the next lecture we'll learn about devices. Thank you.